Good day, everyone, and once again we are back together, and welcome back to our channel. And today we are going to be looking at solving trigonometric expressions or even equations by using a triangle. So I'm not going to waste time and just go straight into a question and give you a couple of rules. So if you haven't subscribed, please just consider being part of the family. Hit that subscribe button. And of course, hit the notification bell so that you are alerted every time that we are posting a new lesson. And for those of you who might need assistance, whether in mathematics or physical science, of course, just reach out to us. And our email address is info@mlungisinkosi.co.za. All right, so let's get right into our lesson. So in this case, if we are given a trigonometric expression and they say solve, or rather, simplify without the use of a calculator. So I'm just going to take one which is quite simple. So suppose we've got the sine. Okay, so we've got the sine. They give us the sine of theta. And in this case, let's say for argument's sake, they tell us this is 4/5, okay? They might give us a restriction again, and they say theta is less than or equal to 90 degrees, and theta is greater than 0. So these are the type of expressions that we are talking about, and they would say, give you a couple of expressions to kind of work through. Now, the first thing that you're going to do, always try to isolate your trig expression. So in this case, it's already isolated. So isolate your trig ratio. Okay, so that's the first thing that you're going to do. And secondly, draw a triangle. Okay, so you're going to draw a triangle. Right, now, how do you draw this triangle? You're going to make sure that it's in the right quadrant. Okay, so of course you're going to look at your restriction. Okay, and of course you're going to look at the ratio that you are given as well. Don't worry, you'll understand all of this as we do it. And then thirdly, you're going to find the third side. Okay, and when you find the third side, you find the third side by find the third side using Pythagoras. Okay, using Pythagoras or Pythagorean theorem. Okay, and then of course thereafter you can now knock yourself out. They might give you double angle identities, they might give you compound angles, and so on and so forth. So those are all the rules that we're going to follow. So I want us to quickly look at the one that I've given you right there at the top. Okay, now what's the first thing that we're going to do? So isolate our trigonometric expression. So in this case, so already we've got sine of theta is 4/5. Okay, so I'm going to draw my my Cartesian plane, and I'm going to do this. Where is the sine of theta? Let's draw a cast diagram. Okay, so CAST. Now please listen to the question. So my first question is, I can see they've given me the sine of an angle and it's positive. Can you see that's positive 4/5? So in my cast diagram, where is sine positive? Okay, so you'll see, all right, I'm going to tick. So in this case, it's going to be in the first quadrant, but it's also going to be in the second quadrant. Okay, so now, because I'm trying to find out where am I going to draw the triangle. And then secondly, I'm going to say, well, look at this. So in this case, they've given me a restriction, and they said that angle must be between 0 and 90 degrees. So where is that in the Cartesian plane? I'm going to do that in green. So in this case, definitely between 0 and 90, that's in the first quadrant. So where I have 2 ticks, that is where I am going to draw my triangle. So in this case, That means that we're going to draw our triangle in the first quadrant. So there's our triangle there. Right, now, what is sine of theta? Sine of theta is y over r, okay? Or you can say it's opposite over hypotenuse. So it means in this case, our y value is 4, okay? So our y value is 4. So it means that's our theta there. So our y value is 4 and our r value is 5. It means our hypotenuse is 5. Now, how are we going to get our x value? We said you are now going to use Pythagoras to get your x value. So in this case, I'm going to simply say, okay, we know Theorem of Pythagoras, x squared plus y squared is equal to r squared. So in this case, I'm looking for x value. So this is going to be r squared minus y squared. So let's substitute. Our y is 5 squared minus 4 squared. And in this case, you'll see this is 25 minus 9. And that gives us minus 16 actually. I'm already thinking about the answer in this case. So that's 25 minus 16, and in this case that would give us 9. Okay, that's x squared is equals to 9. So in this case, what's our value for x? So you'll see every time you take a square root, you get plus or minus the answer. So it's plus or minus 3. But in this case, where is our triangle? It's in the first quadrant. How is x in that first quadrant? In this case, x is positive. So that means that our x value in this case will be equal to 3. Okay, right. So they might give us, different expressions. They might say to you, give the value for, let's say, sine of 2 theta. Okay. So when you've got a double angle, always just make sure that you express it as a single angle, okay? Or when you've got compound angles, sometimes they give us more than one angle, okay? And of course, we are going to unbundle them using the different formulae for double angle identities. Now, let's express sine of 2 theta in this case. So we're going to say, but we know sine of 2 theta, this is going to be 2 sine of theta, and they'll always say without the use of a calculator, right? So we're going to say 2 sine theta, or sine theta is equal to 2 sine theta cos of theta. Now, this means, what is 2 sine theta? This is going to be 2 times, what is sine? Remember, we said sine of theta is y over r, okay? And what is cos of theta? Okay, or if you prefer to use opposite over hypotenuse, and cos of theta would be adjacent over hypotenuse, or in this case, x over r. Okay, so now let's try and express them in terms of those values that we have. Our y value, or in fact, we do have the sine of theta. We're given there, it's 4 over 5. Okay, so that's going to be 4 over 5. But what is cos of theta? Our x value is 3 and our y value is 5. Okay, so in this case we can just simply work out that value there. So we're going to say 4 times 3, that's going to give us 12, times 2, that's going to give us 24. So that's 24 over 5 times 5. In this case, our denominator is 25. So our answer there, without the use of a calculator, is 24 over 25. All right, I hope that makes sense. All right, so in this case, I want us to do some more examples. And of course, we will conclude right at the end. All right, so let's look at our first example. So they say if sine of P is minus 3 over 5, where P is an element of 0 to 70, and the cos of Q is 4 over 5, where Q is or greater than 180 and less than 360, then we determine without the use of a calculator the following expressions. Of course, we've got all of those there. Okay, so the first thing that I want us to do, let's try and work out our triangle. That's what we said. So we first always try to isolate our trig expressions. Okay, so in this case, what do I have? I've got the sine of P, which is 3/5. But what is sine again? So in this case, remember, sine is y/r. So let me just write that in a different color. Okay, so that's y/r. Okay, and cos, we know that's x/r. I'm just going to draw those two Cartesian planes in different colors. Right, so let's draw the one for P first. So where is sine negative? So I can see that my ratio is negative there. So again, cast diagram, where is sine negative? So I know that sine would be negative in the third and the fourth quadrant. Okay, so they've given me a restriction. They said P is an element of 0 to 270, so which means P should exist between the first, the second, and the third quadrant. So where do I have two ticks? In my fourth quadrant, sorry, in my third quadrant rather. So it means that my triangle is going to be in the third quadrant. I hope that makes sense. So let me just erase that so that I can draw that triangle. Okay, so it means that would be my triangle. Okay, over there. Sorry that it's in a corner sitting awkwardly there. Okay, so there is my angle. So that's angle P. So now I need to find out in this case. Okay, so I know that my y value is the one that's going to be negative, because remember, y would be negative here. So that would be -3. And of course, my r value is always positive. Please remember that r is always positive, right? So in this case, then I'm going to look for my x value. Okay, so how am I going to get that x value? Again, we're going to say x squared is equals to r squared minus y squared. So that's going to be 5 squared minus our r is -3, our y rather is -3 all squared. You put that in brackets. Okay, so in this case, that's 25 minus 9. And of course, we're going to get 16 for that. And of course, x is equal to plus or minus 4 when we take the square root. Okay, right. So what we're now going to say is, well, x is on the negative side. So in this case, we're going to choose the negative value, right? So our x value would be -4. All right, now let's draw the same diagram, okay, triangle for Q. All right, maybe let me try and make it different. Okay, so for Q, there it is there. Okay, so there's my Cartesian plane again. So what did they say about Q? Now we've got x/r, it's 4/5. Cos is positive. Now, where is cos positive when we use our cast diagram? Cos is positive on the first quadrant as well as on the fourth quadrant. Okay, now in this case, they told me that Q is an element of 180 to 360. So what they're saying to me is that Q exists between the third and the fourth quadrant. So where do I have two ticks? You've got that right. So in this case, it must be in the fourth quadrant. So let's draw a triangle. Okay, I keep making the same error. Okay, It's very difficult to make a straight line in this thing, but hope you understand. Okay, so in this case, what do we have? We've got cos of theta is 4 over 5. That's x is 4. So my x value is 4. And my r value is 5. Okay, so in this case, I'm going to have to find the y value. So we're going to say x squared plus y squared is equal to r squared. And of course, we know that y squared will be equal to r squared minus x squared. Of course, we're not going to waste time with this. Okay, our r value is 5. Let's substitute our value there. Minus 4 squared. So that will be 25 minus 16. That's y squared. And of course, now to get the value of y. So 25 minus 16 is 9. Okay, but remember, we're going to take the square root. That's plus or minus. So y is equal to plus or minus 3, right? But we need to choose one. So which one are we going to take? Are we picking the positive or the negative value? And it's definitely going to be the negative one because y is negative in this particular instance. Okay, right. So now we need to then go and find the different expressions, okay, that they asked for. The first one, they said we need to work out sine P minus Q, okay? So let's work out the value of sine of P minus Q. Definitely this is a compound angle. So how are we going to do that? Remember our compound formula for sine P minus Q. We would have sine P cos of Q minus cos of P sine of Q. All right, now let's find that quickly. Sine of P, remember what is sine? That's y over r, okay? I won't waste time with that because we already have sine of P. It's minus 3 over 5, right? So I'm going to say that's negative 3 over 5 multiplied by, I said theta in terms instead of Q. Sorry about that. I'm quite certain you still understand. You know, we always gravitate towards this, you know, theta when we express angles. Right, so cos of Q, remember cos of Q, we were also given there. Okay, that's what we had. That's 4 over 5, so I won't waste time with that. So that's 4 over 5. Okay, minus. Now let's talk about cos of P. I'm going to open brackets there. Always be careful about those signs. So cos of P, so going into our first triangle, cos is x over r. Our x value is minus 4. And our r value is 5. So that's multiplied by minus 4 over 5. Please remember to take the sign as well. Okay. And then sine of Q, we're going into our second triangle. So we're looking for the sine of Q. Sine of Q, you'll notice in this case, sine is y. So our y is minus 3. And our r value, so that's y over r, so that's minus 3 over 5. So that will be minus 3 over 5. All right, and ladies and gents, we know how the cookie crumbles in this case. We are going to have those two fractions, so we are multiplying. When we multiply fractions, at least that's a little bit easier because you multiply numerator to numerator, denominator to denominator. So minus 3 multiplied by 4, that will give me negative 12 over 25. And in this case, we've got minus. Now, of course, a negative times a negative there inside the brackets would be positive. So that's negative again, we're going to have 4 times 3, that's 12 over 25 as well. So we've got minus 12 over 25, minus 12 over 25, and what that will give us is minus 24 over 25. And that's our final answer. That is what that expression will give us. Okay, quickly, let's go to the next one. I'm sure you're getting the gist of this. Cos of P plus Q. Okay, using our compound formulae. Cos of P plus Q. Okay, so we know that for cos, you're going to have cos of P, cos of Q. Remember, for cos, we change sign. So when we've got a plus there, it's going to be minus sine of P, sine of Q. All right, so once again, let's go to, for P, that's our first. So I'm just going to steal the values from there. Cos of P, we found minus 4 over 5. I'm sure you're getting the hang of this. Remember that cos is x over r. So at P, okay, which is this angle over here, x is minus 4 and y is 5. So that's going to be minus 4 over 5. Okay, and cos of Q. So I'm going to steal the values actually from our previous example. Cos of Q, which is what we had over there, that was 4 over 5 as well. Okay, minus sine of P, that's what we had. Sine of P, that was minus 3 over 5. And sine of Q, we also had a negative 3 over 5. Okay, you can go back to your diagram, and it would really be helpful if you could draw the diagrams yourself so that you can always, just know what to do. Right, so in this case, what do I have? I've got minus 16 over 25. Okay, again, minus, if I open brackets there, I'm going to have negative times a negative again. That's positive 9 over 25. Okay, so now I've got two values there. So my denominator remains the same. That's 25. And it means I'm just simply going to add the numerators. So it's going to be minus 16 minus 9, which is going to be minus 25. And at the end of the day, I get that to be minus 1. Okay, negative 1. And that's our final answer. All right, you can see how that will be for cos of 2 theta. Or in fact, the first one is sine of 2p. Okay, those are our double angle identities, right? So the sine of 2p, you remember what is our double angle identity for sine? So that's going to be 2 sine p cos p. So at the end of the day, you've got 2 sine of p. Let's see there. I think sine of p was negative 3 over 5. Minus 3 over 5. Please, you'll correct me if I've made an error there. And cos of p is, okay, let's see, cos of p was negative 4 over 5. Negative 4 over 5. And in this case, of course, we can try to work that out. Negative times a negative again. Okay, that would be positive. 3 times 4 is 12 times 2. That's 24 over 25. And of course, I'm sure you can do that the same for cos of, I think we had cos of 2q. Okay, and by the way, for cos, you can choose any of the ones that we have. Okay, if you don't mind, let me just take 2 cos squared. Yeah, it's 2 cos squared. Yes, I am correct. 2 cos squared of q minus 1. Or you could have chosen cos squared of q minus sine squared of q, or 1 minus 2 sine squared of q, all the same, you will get to the same answer. So it's going to be 2 into cos of q. Now, if you remember, cos of q in that case, what is that? Cos of q was 4 over 5, okay? Cos is x over r, so that's 4 over 5. So I just chose that one because we only have to deal with one trig ratio. 4 over 5 squared minus 1. And by the way, even if you chose the others, you're still going to land at the same point, okay, with the same answer. So this is going to be 2 times, that's 16 over 25 minus 1. Okay, so in this case, that's going to be 2 times 16 is 32, okay, over 25 minus 1. Okay, for those of you who know fractions, what you can do is that you can just express that as 32 over 25. To make it easier for yourself, you can make 1 into a fraction of 25. So it can be 25 over 25. Okay, and so what do you have at the end? Okay, we have 25 there as our denominator. Okay, so 32 minus 25, that should give us 7. Okay, so our final answer would be 7 over 25. All right, so that is how you would do that question. All right, and I just want to take one last question, which has to do with a variable. All right, so let's look at the third example. All right, so they say given that sine of 17 is equals to k, express in terms of k those different ratios. So in this case, what we're going to do is that nothing is different, okay? And by the way, just keep in mind, you know, they might give you restrictions and so on and so forth. In this case, we need to always be mindful of that, okay? Right, so they've told us that sine of 17. Now, please note, that's in the first quadrant. It's quite obvious, so we don't need to be given any restriction because they've actually given us that particular angle there. It's not a variable. So what we're going to do is we're going to go and draw our triangle. Okay, just remember. So we go into the Cartesian plane. We know our triangle is in the first quadrant. Okay, and they've said that the sine of k, or of 17, is k. Now, please, I want you to note something. So that means that sine of 17 is, now I want you to think about it. This is the same as just simply saying k over 1, okay? And the reason why it's important to put that 1 there, because remember, sine is a ratio, y over r. So what does that mean? It means that y is equal to k. So our y value, gonna put that in yellow, is positive k. And what's our r value? Our r value is 1. Okay, so then we'd need to get the x value, and in this case we did say that we use Pythagoras, so that's x squared plus y squared is equal to r squared. So this will be, we're looking for the x value, so x squared is equal to y squared minus r squared, and in this case this is simply going to be 1. Okay, you can say squared, okay, minus, even though we know 1 squared is 1, minus our r value is k. So that's going to be k squared, okay? Of course, it would be important if it was negative, put it in brackets. So x is equal to 1 squared minus k squared, or rather x squared is equals to 1 minus k squared. Let me put it like that. And so as a result, x would be equal to the square root of 1 minus k squared. Now, please be careful not to say that 1 minus k squared is equal to, 1 minus k. It's not the same, okay? So that would be plus or minus, but which one do we pick? Of course, it's going to be the positive because x is positive there. Just going to write it in green. Okay, there's my green refusing. So this is going to be 1 minus k squared. All right, so now we've got the value for x, y, and k. So we just need to now find the different expressions. Okay, I was very deliberate about picking this one because, of course, it requires us to go back into our reduction formulae as well. Okay, so cos of 73. All right, so let's find the first one. Let's express cos of 73. Now, you might be wondering, but we're dealing with 17, but what is cos of 73 doing there? You'll remember that cos of 73, okay, so this is the same as cos of 90 minus 17. And remember, once we have 90, it means we need to change into our co-ratios, isn't it? So cos of 90 minus 17 would be the same as sine of 17. I hope you remember that. Okay, so sine of 17, remember sine is y over r. So our y value is k and our r value is 1. So in this case, that will be equal to k. All right, so this is just simply k when we simplify. And then let's go for the second one, right? So what do we have on the second one? They said cos of negative 163. So we've got cos of negative 163, right? Remember, what we did say is that whenever you've got a negative angle, remember, all you simply do is just add 360. So I'm just going to do that. Remember, once you add 360, it remains as is, right? So I'm going to say this is cos of 360. So I'm adding that 360 minus 163. Okay. You'll realize, so you get 360 minus 163. So let's get that. Minus 163. And I get 197. Okay, so that's 197. Okay, now how do I express that in terms of an angle of 17 degrees? So this is the same as saying this is cos of 180 plus 17, right? Okay, so again, looking at our cast diagram, where is cos of 180 plus 17? It's in the third quadrant. Okay, so let's write that cast there. Okay, how is cos in the third quadrant? It's negative. So this is the same as saying negative cos of 17. Okay, now, so that's minus, remember, what is cos in this case? Cos is x over r. Our x value is square root of 1 minus k squared. And our r value is that 1 there. So that's square root of 1 minus k squared, okay, divided by our r value is 1. And so that will be minus 1 minus k squared. All right, so that is our final answer for that one. Okay, let's go for the third one. So we've got 10 of 197. Okay, so our C, they said 10 of 197. Okay, and of course, what is 10? Okay, first of all, let's write it as a compound angle. Of course, you can see how that will be, again, 180 plus 17. Okay, that's in the third quadrant. Okay, what does our cast diagram say? It says in the third quadrant, 10 is positive. So that will be the same as 10, 17. Okay, so as a result, and of course, if you haven't watched our first lesson on trig, on the reduction formulae, all right, please just make sure that you go and watch that lesson so that you know how to go about tackling these. right? So in this case, 10 of 17, that's going to be y over x, that's 10. So our y value, remember, so that's y over x, so that's k over square root of 1 minus k squared. So that's y over x, so our y value is k, okay, and our x value, we said that's square root of 1 minus k squared. Of course, if you want to, you can just rationalize that. I'm just going to leave that for now. Just leave it as is, okay? Especially if I was not asked to rationalize. For those of you who want to know what rationalizing is that you try to remove the surd at the bottom, and how you do that is that you multiply by, in this case, the same surd, okay? But remember, for you to make sure that it is the same thing, that's 1 minus k squared, okay? So what do you end up with? You end up with k multiplied by 1 minus k squared at the top, divided by, at the bottom, you'll have 1 minus k squared, okay? This is you trying to remove the, the surd at the top, okay? But I'm just going to leave it there, okay? There was nothing wrong if you left your answer exactly there, okay? We'll talk about rationalization in future. Right, and then the very last one, we've got cos of 326. Okay, so I've got D, that's cos of 326. Okay, let's see. So cos of 326, let's see, if we said 360 minus 17, okay, I get 343. Okay, did I copy that correctly? Okay, so that's okay, so 17. All right, I think that might be a double angle there. Okay, all right, yeah, actually there it is there. Now you'll see how this can actually be cos of 360 minus, okay, so that's 360 minus 34. All right, yes, so that's minus 34, and in this case you get the cos of course. What does cos look like? And I chose 34 because I could see that 17 was not giving me that value there. All right, so going back into our triangle, you'll see there's no 34 there, but in this case 17 multiplied by 2 is 34, and it looks like to get that value there, I would have to have cos of 360 minus 34. But then where is that? Cos, that's in the fourth quadrant, and we know cos is positive, so we end up with cos of 34. Right, and you'll see cos of 34 is the same as saying cos of 2 times 17. Okay, so that's a double angle identity. So this is the same as 2 cos 17 sine of 17. I hope this you find this incredibly helpful, right? So in this case, we're going to say, well, that's 2 times, okay, so that's cos of 17. Remember, that's x over r. Our x value is square root of 1 minus k squared over r, which is 1, and our y value, if you remember there, our y value is k, okay, so just verifying that with you, okay, our y value is k, so multiplied by k over 1. And of course you can try to simplify that, so that's 2 in fact, let me just write the k there. So that's 2k multiplied by root of 1 minus k squared. And of course, all of that divided by 1. So which is exactly that at the end. All right. And that is how the cookie crumbles when it comes to these. Right. As per usual, what I would like to do is just give you one last exercise. But this one you're going to do on your own, right? Please just give me the answers, of course, on the comment section. All right, so I want you to please work this out for me. If you take, so 5 cos, right? So I'm trying to write this down here. So 5, the cos of x plus 4 is equal to 0. Okay, so this is the expression that we have, okay, without the use of a calculator, right? And so cos, okay, so x is greater than 180 and less than 360, okay? And then I want you to work out the following the following expressions. 5, the sine of x, okay, plus 3 10x. And b, I want you to work out 10 of 2x. Please give me those answers, okay, in the comment section. I will appreciate that very much because it tells me that you actually have learned. All right. Just to give you a hint on that one. So remember to isolate your trig ratio. So just to show you quickly, remember that when you're supposed to isolate, just make sure that you have 5. Okay, let me just write it in a different color. So you've got 5, the cos of x is equal to minus 4. All right, and what you do is then you isolate your trig ratio. I'm going to divide both sides by 5. So I end up with cos of x is equal to minus 4 over 5. Of course, you would have cancelled those two. And of course, you can now work out that those two expressions. Please write down the answers in your comment section. All right, and if you liked this lesson, just click on the like button. And of course, I am going to wrap it up here. All right, and thank you so much for watching. Please don't forget to subscribe, and please tell as many people as you can about this channel. We will continue to dish out that good content for you and for your benefit. Okay, otherwise from me for now, I will see you guys next time. Sharp, sharp.